My name is Ravi Starzl. I'll be delivering the talk on generative AI and cyber ops. Just by way of background, I'm an adjunct professor at Carnegie Mellon University, also University of Colorado at Boulder. And I also work with Army Cyber Institute on some of the things that I'll be talking with you about today. I'm very excited to talk about this topic. It's a hugely important topic. And I have a lot of material to cover. So what I plan to do is talk through the material. And then if you have any questions, I have my chat window open. Please drop the chat questions in there. It'll also be around the conference. Talk to me separately or go over to my LinkedIn page, and I'm happy to follow up offline as well. So I'm going to share my screen now and get started with the talk. And please, as I said, feel free to drop your questions in the chat as you come up with them. The imperative of generative AI and cybersecurity is that the landscape is rapidly evolving. With the development of large language models, what we've been able to do is essentially turn the process of using language in some kind of automated fashion to do important and meaningful work into a reality. It's gone from science fiction to something that we can all play with the likes of ChatGPT, Google's Bard, Meta's Llama, and there's many other forms of large language models out there. It's probably the fastest adopted technology in the history of humanity, and it is literally just getting started. Unfortunately, it's also beyond human scale, and a lot of this development is being oriented towards malicious activity, cyber threat intelligence, or cyber threat activity, and information operations. It's also, because of the nature of large language models, cross-lingual, meaning the boundaries between needing to speak another language have effectively disappeared because the translation capabilities of large language models are extremely advanced. In many respects, large language models were a byproduct of an attempt to come up with a better translation mechanism. That's where they were originally invented as an improved translation system. And so they're very effective at translating, at last I heard, pretty fluently between 90 different languages. So you can be operating in Russian, German, Mandarin, or English and be cross-conversant fairly easily. What can be handled with standard system information and event management systems is largely being surpassed in terms of the kinds of machine learning or pattern recognition capabilities that are available in those systems. The arc of this presentation has 4 major sections, each of which I'll try to cover in rapid order here. So I apologize if I go a little bit fast, but as I said, I'm very accessible. Please reach out to me and I'm happy to go through any of these in more detail. And I'm also very open to collaborations. Section 1 is our generative AI overview. So given that this is kind of a somewhat educational conference, somewhat industry-oriented conference, I thought it would be useful to explain to folks how it works. So just a quick definition of terms, generative AI is generally the class of systems that interpret and generate useful output of at human levels of utility, meaning you can talk to it and it talks back to you. Large language models are a particular class of generative artificial intelligence trained on really large amounts of data, but there are many other forms of artificial intelligence that could also be called generative. Text generation is just one common case. I think one of the most important things to realize about the way large language models work is that the bottlenecks are training data and task definition. If you go talk with ChatGPT, it performs very impressively across a broad range of domains. But if you really try to dig down and get into specifics or go deep, it frequently breaks down either by hallucinating or by not being able to respond to you in an adequate way for real work to get done. Those are generally caused by byproducts of not having enough training data or not having an adequate back-end task definition built into the way the model was created. And so I believe the future is going to move more and more towards specialized artificial intelligences that are going to be able to have sophisticated conversations over specific topics. For example, cyber operations or cybersecurity will become a specialized form of artificial intelligence. In that same manner, administrative artificial intelligence to handle administrative tasks will become a specialized form of large language model. And this will really unlock the future potential of what AI can do. The broad overview of how an AI is trained of the large language model type is you have a huge amount of training data. Let's just use the text generation case as our example. And all of that training data is essentially embedded into what's called a vector space. That means all the words are turned into numeric representations of that vocabulary and the relationships between all of those words. And there's something here called an attention mechanism. That's really the reason large language models have become such a breakout success, which is it's not just a uniform number assigned to each word. The number also captures how important each word is to each other word. In other words, the affinities of co-occurrences of words in the language are also represented by this process. When you give a prompt to one of these large language models, the same vector embedding and transformer attention process is applied to your prompt. The two are synthesized, and the generative AI creates what's called inference, or essentially guesses what a good response would be. And that is the output that it hands back to you. GPT just means generative pre-trained, which means it's a generative model pre-trained on a very large amount of data. The one thing to keep in mind about the domain of cyber ops and cybersecurity is that it's very different from long wiki articles or tweets, in that the data is very spread out and oftentimes very code oriented, and oftentimes has an intermixing of code and special domain language, as well as regular human language. And so this is another area where the kind of work where we're building specialized artificial intelligence is going to make a difference. I kind of already explained how vector embeddings work at a high level, but just as an intuition for what attention means, if I say I love red apples as an example sentence, love and red are not very important to each other in the context of this sentence, but love and apples are more important to each other. I and apples are much more important to each other than I and red. And so in this way, hopefully you can start to see there's an intuition between the higher the weighting, essentially, or higher the numeric representation of a word in the vector embedding space or a token, the more affinity it has for the other elements of that sentence. And for anyone who's a deep expert in the space, please forgive my high-level explanation and treat it with a bit of artistic license. This is more meant to give a sense of, try to grasp how this works, and that there's a real method to this madness, or there's a real science underlying all of this, and that large language models are not black boxes. They're also not sentient. They are computing machinery, and how they work can be very clearly understood, even if some of their aspects are extremely complex and sophisticated at scale. But they can be designed to do very good work, and thankfully we've reached the point where we can actually start to do that. Now, the way that essentially your prompt and the underlying training data is synthesized to create a kind of response is it takes the vector of your prompt and the vector of the underlying training data, and it synthesizes these two things, or conducts a dot product operation, which just means it multiplies these two vectors together in a particular way to create a number. The bigger that number, the more unrelated; the smaller that number, the more related. Essentially, it's a measure of relatedness. I'm sorry, I think I got that backwards, but the smaller the dot product, the more related those two are. To generate a response, and of course, I'm happy to go through this in more detail at another time. The prompt is encoded. The model that's been pre-trained on data already has encoded data. The prompt is fed into the same layers of the model that the training was done on, and an output, which is essentially a distribution of potential responses, is created. And then repeatedly, the model samples from that distribution, one token at a time, in an autoregressive function, meaning it just feeds what it's already come up with into as part of the response process, and its response is sequentially formed. That's why it looks like a typewriter when it's generating a response to you. Transformers get their apparent intelligence from your prompt, and they get the other parts of the apparent intelligence from the underlying training data. Transformers are not generally intelligent things yet, and they are not sentient things. They're not true thinking things in that sense. What they're doing is they're borrowing the apparent intelligence and the way human language is used naturally on the internet, which is where the primary place most of these large language models are trained, and the inherent intelligence embedded in the way you've asked your question or the prompt you've given it. And so that latent intelligence that is an inlay in how the questions and the data are encoded, meaning language, is reflected back to you. So it looks intelligent, but it's actually doing fairly straightforward linear algebra operations or matrix mathematics. Now, the way these systems work is they're largely reliant on human feedback loops to generate really high quality data. Humans annotate the data, they provide feedback to the system to a class of separate artificial intelligence models called reinforcement learning models. Those reinforcement learning models learn how the human annotators think about the quality of a response the large language model is generating. And then those reinforcement learning models help train, scale up effectively the feedback and help train the underlying large language model further. So this is a kind of network of artificial intelligences that are strung together to help train each other. So with that in mind, let's talk a little bit about how all of these things apply to cyber ops specifically. And maybe for anyone who really works in the area, it's already very evident. Generally speaking, cyber ops is already a giant problem space because there's tremendous threat. There's no such thing as secure software anymore, but now I think the problems have become amplified in many interesting and new dimensions by the emergence of AI. And all major organizations are coming under increased threat because of it. AI will simply make hackers more capable by orders of magnitude. And in generally speaking, the way that they will make things more difficult for blue team people, for people who are trying to protect against cyber operations, is they will enable greater offensive planning, greater offensive coordination, and greater offensive execution at scale with essentially infinite patience and persistence. And so it just makes it very hard to, and they will also have a strong ability to cloak themselves because they're operating within the very networks that are being used to detect them. I believe the future in I believe the future of cyber AI and cyber ops is in what I'm calling synthetic cyber teams. And this is essentially a teaming of a human and an artificial intelligence where the AI is a specialist large language model type AI, and perhaps a network of these large language model AIs that are trained on specific data sets relevant to cyber operations. And the human has an interface, an interactive interface, an intelligent user interface with the synthetic cyber operator. And it explains to the synthetic cyber operator what they're trying to do, how they're trying to do it. And the synthetic cyber operator then gives useful responses back, such as assessments, attack plans, remediation steps, cyber threat intelligence, etc. And in this way, humans stay in the loop where they direct the artificial intelligence to conduct the work that's important. And the artificial intelligence is able to do the heavy lifting or the shoveling of the large amounts of coal that are normally the huge amount of tedium that's normally associated with good cyber operations work. It'll greatly enhance cyber defense and provide a competitive advantage when deployed properly. A synthetic cyber team is really a game changer. Now, eventually, we all understand that what we want is full cognitive cyber ops AI, but that's still a ways off. And that's simply because AIs tend to run off the rails. When they're left alone to essentially auto-regress their own motives or their own objectives, they tend to just actually run off the rails in random directions, and they're very hard to direct. So AI-assisted cyber operations or synthetic cyber teams are going to be the step of the near future. And then eventually, I have no doubt, full cognitive AI will eventually emerge. So I'd like to give some specific applications where cyber operations have application today. I believe cyber exploitation planning is an immediate low-hanging fruit, and that's where huge amounts of cyber threat intelligence data is organized and analyzed by an AI, and a human then interfaces with that AI and that data set conversationally and creates personalized exploitation plans for target systems. And then the AI can not only help form those plans in the same way that they help write a term paper for students, but they also are able to augment through some basic interfaces on the back end of a specialized tool using type of AI, execute those exploitation plans according to human operator commands. I've actually done this now myself, and this is a small demonstration where I created a fully local large language model using LangChain Hugging Face embeddings and Google's FLAN large language model, where I used 198,000 reports from CVE, Common Vulnerability and Exploits or Exposures details There's no reliance on OpenAI or any other paid API provider. So no one knows what I'm doing. And no one knows, not only does no one know what I'm doing, no one can stop me from doing it. I had a conversation with it where I said, I want a vulnerability for Windows Server 2022. I said there's several bypass vulnerabilities. I want the one with the highest CVSS score in 2023. That's a stupid question, I know, but it's just a demo. And it comes back to me and says, okay, BitLocker security feature bypass has the highest score of 6.6. And at the time that I wrote this presentation, that was the highest CVS score, and it's a local exploit. I didn't know anything about this before the AI told me about it. I then asked it to bring me all the vulnerability to exploit this, and it synthesized a CSV file that contained essentially all of the code examples that were submitted as part of these bug reports from various hacker sites connected to the CVE exploit databases. It goes without saying that AI and social engineering is going to be a huge problem. Automated scam callers, automated, highly sophisticated, long-winded, long-running phishing attempts will have to be defended against. I'm running short on time, so I'm accelerating my pace. I apologize, but I'm happy to go through this in more detail with anyone who wants to continue the conversation. And AI and cyber threat intelligence is another tremendous low-hanging fruit where it explores algorithmic systems, code, hacker sites, sensors, technical reports, human experts, and synthesizes all of that data underneath a single system that you can literally have a conversation with and generate automatic documentation of relevant cyber threat intelligence on demand. I did this again, for example, using that same setup I described earlier, where I was able to discover a vulnerability in the infrared camera system, which is a it's a Internet of Things industrial camera. And this is a fairly significant oversight, which is that there's a blank root password for Telnet by default built into that system. So if any warehouse has any of this infrared iRay model cameras, I can just put my eyes into your warehouse that's not even an exploit. That's just an oversight. And again, I had no idea that this existed until the AI was able to talk to me and guide me through all 200,000 of those CVE reports. I'm just getting started. Imagine when you add in all of the open source resources that are available, the hacking is as old as the internet, and there's a lot more to be integrated. It can be incorporated into threat hunting. It can be incorporated into darknet discovery. I think you get the theme here. There's really no limit to how useful or dangerous this could be in the world of cyber ops. I think building good generative AI capabilities into your cyber ops teams is extremely important in the coming era. And the way I would suggest doing that is by building a team of experts, developing deep expertise and understanding what these large language models are good for and what they're not good for. And I would say identify the use cases. That's going to be the most important thing. Don't just build in general, build to purpose. Then develop a strategy for solving that particular use case that you have in mind, and then implement and evaluate the results. If you just go on an open-ended phishing expedition, you'll almost certainly get lost in the process. So try to anchor your efforts in a specific objective, then build a strategy around accomplishing that objective, then evaluate the effectiveness in accomplishing that objective, and then move to the next one. I think the conclusion that I'm making is that it's super important to pay attention to this. The cat is already out of the bag. No one will be able to put this genie back in the bottle. I'm going to come up with more analogies, but in reality, this simply cannot be stopped. OpenAI trying to censor or filter its responsiveness won't stop this because the architectures are known. And even if good actors on the US side of things or the Western world try to mitigate the impact of these technologies, that will not have any impact on bad actors in other parts of the world. So we all will have to deal with this together. And I think it's really important for us to start building the expertise together. Someone asked if the presentation deck is accessible. I will go ahead and make it accessible to the organizers, but you can also just reach out to me directly, and I'm happy to share this deck with whoever is interested and talk through it in more detail. So with that, I'm right on time, and to avoid being rude to the next presenter, I'll go ahead and end this presentation on time. but I really appreciate your attention, and I hope that was valuable to someone. And I would love to follow up further. So thank you very much for listening, and I look forward to hopefully following up with some of you in the near future. Thank you.